Hello, dear students. Today we are going to discuss the topic that is based on substitution reactions. So, today's topic is substitution reactions. Substitution reactions. So, this is basically the topic of organic chemistry. So, dear ones, first of all, we just want to hear substitution reactions. All the people know about the reaction. There are two types of reactions which is based on inorganic chemistry as well as organic chemistry. Inorganic chemistry's reaction are totally different as that of organic reaction. Here I just want to introduction regarding the substitution reaction, and substitution reactions are part of reactions that is basically in haloalkanes or haloarenes, that is a part of organic chemistry. So first of all, I just want here explain substitution reaction. So dear ones, dear students, today we are going to teach, today I am going to teach, I am going to deliver a topic that is based on substitution reaction. So what are substitution reactions? First of all, what are substitution reactions? What are substitution reactions? So this is one of the most important topic that is in the organic chemistry, especially in haloalkanes or in haloarenes. So first of all, substitution reaction. But as substitution reactions, dear ones, substitution reactions are those reactions, substitution reactions are those reactions in which an atom or group of atoms are replaced by another atom or group of atoms. So here the definition of substitution reaction is: substitution reactions are those reactions in which an atom or group of atoms are replaced by another atom or group of atoms. Or we can say an atom or group of atoms present in a reactant substituted by another atom or group of atoms. So basically, when we define here substitution reactions, you just set an example that is based on cricket. If there are 11 players in a cricket, if there are 11 players to play a cricket, because the rule of cricket is based on 11 players. If you have 11 players in a ground, someone gets injury, someone gets wounded, someone gets sort of a problem, and you want to change, you want to replace that player, you want to substitute that player. One player is replaced by another player, one player is substituted by another player. Basically, overall cricket team comprises of 11 players. one player is substituted by another player, one player is replaced by another player, that's known as substitution. So here same set of example explains here what are substitution reactions. Substitution reactions are those reactions in which an atom present in substrate or in reactant gets replaced by another atom or gets replaced by group of atoms. Those are known as substitution reactions. Basically substitution reactions are explained by examples. However, I will show here a type of example which basically explains here substitution reactions, and you will feel good pleasure regarding the substitution reactions. What are substitution reactions? Take an easy setup, take an easy thing in the substitution reaction. So here I will rub the board, and I know that you have got this point, what are substitution reactions. Now I would like to show here a type of example that gives you a good explanation regarding the substitution reactions. So here I will show an example. So what is the basically example that shows substitution reactions? So here is a B. If there is a B here, substrate AB, this is substrate or reactant. This is reactant. And AB is a substrate or reactant, and you want to take here Y. And Y, B is replaced by Y. B is replaced by Y, or Y comes in place of B and B removes, B replaces, or we can say the B which is connected to A, that gets replaced by, or that is replaced by, that is substituted by Y. So here the example is, we have a product here AY plus B. So here in the substrate B was present, but when AB is substrate, AB is reactant, that combines with Y, Y comes at the place of B, and we found here product that is AY, and B gets replaced by Y. So here the product is, this is the product. This is the product. So these are reactants and this is the product. This is the product. So here I will explain. B is replaced by Y and the product is formed here AY, and B is replaced by Y. B removes only because of when Y is here. So this sort of reaction, if we will see here, two types of atoms are present, AB, and if I will see here in the product, two types of atoms are present, AY. So the ratio of atoms are same in reactant as well as product. This sort of reaction, while the number of atoms are same as well as in reactant as well as in product, that's known as substitution reaction. But here the condition is one atom is replaced by another atom. The position where B is present, now Y comes in place of B, that's known as substitution reaction. So this is overall that I have general example here that is basically show substitution reaction. Now I will show an example regarding the substitution reaction. Basically in advance I have explained, I already told about the substitution reaction. Those takes place in haloalkanes, and now I will show here example regarding haloalkanes, how substitution reactions takes place and which type of example explains substitution reaction. So here is the example. Now got this point, I know that you have got this point. Now write down this one example. Here CH3Br is present. This is known as haloalkane. This is known as haloalkane, or you can say the name of this member is alkyl bromide, or you can say methyl bromide. Methyl bromide. Methyl bromide. Now you want to replace here B, and I will take here OH, because you know in the covalent bonds their atom which shows high electronegativity, they develops del negative charge, and the atom which shows less electronegativity, that shows del positive charge. During the formation of covalent bond, we define polar nature. Polar nature is del positive and del negative. Del negative is because of those atoms show high electronegativity, and del positive is because of those atoms or groups show less electronegativity. Here, here you will see this is negative charge OH, because oxygen atom is highly electronegativity atom, so it develops high electronegativity. So here negative is present, here negative is present. Negative is replaced by negative, and those are known as substitution reactions. Here I will show B shows here negative charge, and that Br gets replaced by OH. Now we have a product here. Easily you will got this point. Now CH3 combine CH3Br, that combines with OH, and OH comes in place of Br. Now the product is formed. What type of product? CH3OH plus Br. So this is overall methyl bromide, and I take here hydroxide ion. Hydroxide ion comes in place of Br, and the product is formed CH3OH. This is known as alcohol, and what type of alcohol? This is known as methanol. So write down, methanol is formed because of an alkyl bromide, or you can say methyl bromide, that combines with OH, and OH, where OH comes? That comes from another reagent, that comes for NaOH, that comes for KOH. Actually the reaction takes place like in this manner. You will see here this type of reaction actually defines here like in this way. So CH3 Br plus NaOH. NaOH is reagent. NaOH is reagent. That's known as sodium hydroxide. And sodium hydroxide gives OH negative. That gives OH negative. So whenever reaction takes place like in this manner, so after arrow, the product is CH3OH plus NaBr. The product is like in this form. So Br gets replaced by OH, but Br combines with Na, forms NaBr, and here the product is formed CH3OH. CH3OH is methanol. CH3OH is methanol. And CH3Br is methyl bromide. Methyl bromide. Methyl bromide. So methyl bromide combines with the reagent that's known as sodium hydroxide, and product is formed CH3OH, that's known as methanol, plus NaBr gets removed because Br combines with Na. This type of reaction is known as substitution reaction. Now in substitution reactions we have two types of mechanisms that show different types of substitution reactions. What type of substitution reaction? Here I explain. this is basically a type of example. Otherwise substitution reactions have so many types, but here I will show general substitution reactions. Now a type which is based on substitution reactions, that is basically takes place in haloalkanes, that's known as, write down, in haloalkanes two types of substitution reactions takes place, or we can say two types of mechanisms. Now in substitution reactions in haloalkanes, write down, in haloalkanes nucleophilic substitution reactions, nucleophilic substitution reactions are to be explained. Now, what are nucleophilic substitution reaction? First of all, I just want to show here representation, format. What are the letters which are to define substitution reactions? Basically, nucleophilic substitution reactions, here, write down, nucleophilic substitution reactions, nucleophilic substitution reactions are to be defined or represented as SN reactions. So SN is nucleophilic substitution reaction. N means nucleophile, S means substitution. It is not nucleophilic substitution reactions where, write down, where nucleophile is used, or you can say in nucleophilic substitution reactions, write down, nucleophilic substitution reactions, nucleophilic substitution reactions are represented as SN. So nucleophilic substitution reactions are those reactions where nucleophile is used, and nucleophile means here, nucleophile is represented by like in this form, or in this form, and you add a negative charge, or you can say NU, two dots are to be defined. Two dots means two electrons. You can write down NU like in this form or in this form, that's nucleophile. So here you will see CH3Br. Br shows del negative. So Br is nucleophile. You can say weak nucleophile. And plus OH. OH also shows negative charge. Both Br and OH are nucleophiles, but one is weak nucleophile and OH is strong nucleophile. Strong nucleophile. So weak nucleophile is replaced by strong one to get the product CH3OH plus Br. So here you will see weak nucleophile you can also define in another way. A weak nucleophile is replaced by strong one, that's also known as substitution reaction, or you can define it in another way. Weak nucleophile is replaced by strong one, that's known as nucleophilic substitution reaction. Now in nucleophilic substitution reaction, two types of mechanism are to be defined. Write down those mechanisms, SN1 and SN2. So write down, in haloalkanes two types of mechanisms are to be defined, SN1 and SN2. SN1 means nucleophilic substitution reaction. Write down nucleophilic substitution reaction. Nucleophilic substitution reaction unimolecular. And SN2 nucleophilic substitution reaction bimolecular. So write down SN1 represents nucleophilic substitution reaction unimolecular, nucleophilic substitution reaction bimolecular, or you can write down unimolecular nucleophilic substitution reaction. And this is bimolecular nucleophilic substitution reaction. So both ways you can explain. So now I will explain one by one SN1 and SN2. First of all, I will show here SN2 mechanism. So write down SN2 mechanism. So write down bimolecular nucleophilic substitution reaction. So that is represented by SN2. So what is SN2? Bimolecular nucleophilic substitution reaction. Bimolecular nucleophilic substitution reaction is a type of reaction, is a type of mechanism where two types of substrates are to be involved at the same time to get the product. Yeah, we can say both substrate as well as nucleophile simultaneously react each other to form the product. That we can say in substrate weaker nucleophile is replaced by strong one at the same time, or we can say simultaneously to get the product. Or we can say, I will show here example regarding the SN2 mechanism. So SN2 mechanism is a type of mechanism. Write down, is a type of mechanism in which weaker nucleophile is replaced by strong one, in which weaker nucleophile is replaced by strong one, or we can say simultaneously, or we can say is a type of mechanism in which weaker nucleophile is replaced by strong one, or we can say in a weaker nucleophile present in substrate gets replaced by strong one. At the same time, or simultaneously. That is, if I will show here example CH3Br, this is substrate where weaker nucleophile is present. This is substrate. Plus OH. Plus OH. That is nucleophile. Strong nucleophile. Strong nucleophile. Strong nucleophile. And the product is CH3OH plus Br. CH3OH plus Br. Now, what type of mechanism I will show here, what type of format I will show here, so that SN2 is defined. So write down, this is overall bimolecular nucleophilic substitution reaction or SN2. So write down, the mechanism of SN2 can be shown as, so write down, mechanism of SN2 can be shown as, so C H H H, here is Br. Now OH does not come along the Br side because Br nucleophile, OH is also nucleophile. If OH comes along the Br side, then repulsions are created because you know Br shows negative charge and OH also shows negative charge. Both contains high electron density and repulsion is created, no product is formed. So what is the basically SN2 mechanism? OH comes along backside of the CH3Br molecule. Now OH comes along in this way and attacks, because you know here Br is front side, OH comes back side. When Br is front side, OH comes back side. This is the easy attack from the back side and naturally product is formed. So OH does not come along the Br side because repulsions are created, no product is formed. So OH comes from the back side, and here H, they create little repulsion, not more repulsion, which becomes barrier towards OH. No. So OH easily come along the backside or backside of the carbon which is present in the molecule, which is present in the substrate. So both CH3Br as well as OH simultaneously react each other. A type of tension is formed. Now what type of tension is formed? You get arrow here. So what type of tension is formed? Dear ones, dear students, I will show here C H H H, here Br can be shown like in this way, and OH comes along backside of the carbon where format the bond between carbon and OH. Here I will show like in dotted form because here bond is formed. Write down, bond is formed, and here breaking of bond takes place. So both, this is known as transition state. And transition state is formed because pentavalent carbon is defined here. Not this intermediate, this transition state lives only a short period of time up to when OH fully formed, completely covalent bond with the carbon, and Br replaced by OH. Br removes then, and product is formed. But this sort of transition state is formed. Backside attack takes place through OH carbon, and front side Br removes. After that, product is formed. This sort of transition takes place in SN2. Now, why we define here SN2? Because two molecules are involved during the performance of reaction. One is substrate and another is nucleophile, strong nucleophile, which takes place, which removes Br, and then nucleophilic substitution reactions are defined. Now, which type? SN2. SN2 means two, bimolecular, because two molecules are involved, OH and CH3Br at the same time, simultaneously, product is formed. Now, transition state is formed. This is also intermediate state is formed, which shows pentavalency, and pentavalency is unstable compound. Pentavalency of carbon is unstable compound, because carbon only shows tetravalent character, not pentavalent character. So with the result, at the same time, product is formed. Now product is formed like in this way. Product is formed like in this way. OH completely forms covalent bond with carbon, like in this way. Now this is the tetravalent. This is formed methanol. Now you will see here Br removes, then Br removes. Now Br was weaker nucleophile that gets replaced by OH, but OH comes through the back side, then product is formed. First of all, you have just defined here transition states. The reactions which show transition state, those are also known as concerted reactions. But I will show here OH comes through backside. So backside attack is possible. Backside attack is very beneficial in SN2 reaction, because that does not come through the front side, because front side also contains Br. Br create repulsion with OH, so product is not formed. So when it comes through backside, product is easily formed. This sort of reaction you will see in the reactant, in the substrate, Br was present. Here I will show. Br was present on front side. Now you will see in the product OH is present and the back side. Now we will see, if you will see, this example is just similar to that of umbrella. When you take umbrella in the rainy time, in the rainy season, we will find little bit storm, little bit wind takes place. After the wind, the part of umbrella that gets inverted. Inverted means like umbrella is like in this form. This is the exact shape of umbrella. When a little bit wind or storm takes place, storm or wind comes, the shape of the umbrella is like inverted in this form. Same, you will see CH3Br is the original configuration of the molecule. But in SN2 you will find the molecule forms, which is the product that gives inverted configuration. So this is overall different configuration. This type of phenomena where the substrate shows one type of configuration and the product shows another type of configuration, this is known as inversion. So write down this very important point, inversion. So inversion takes place at the time of SN2, because backside, through backside OH attacks, and front side is present Br, weaker nucleophile. Weaker nucleophile only removes when OH attacks on the backside. During the backside attack, OH attacks on carbon little bit temporarily first time, and then the covalent bond formed slowly, and Br removes slowly, and the product is ultimate product is methanol. So methanol's configuration and methyl bromide's configuration is totally different. This is basically inversion configuration, where a substrate shows one type of configuration and product shows another type of configuration. This type of phenomena is known as inversion. So overall, inversion is a process just like you will find the umbrella is first shows like in this configuration, and after the storm or wind takes place, after the storm or wind comes, the configuration of umbrella is just inverted. This sort of configuration, this sort of phenomena, this sort of process is known as inversion. So in the SN2 phenomena, inversion takes place. I know that today you have got my lecture very easy way, because each and everything in SN2 I explain, and this is a little bit SN2. After that there is another type of lecture that is based on SN1, but during the SN2 reaction I have really tried a lot to explain each and everything which explains SN2 reaction, and I will show here the format, what type of transition state is formed, why we say SN2 reaction. Now we have a question. You know, in the haloalkanes we have three types of haloalkane: primary, secondary and tertiary. Now best way to find out SN2, which type of molecule easily shows SN2 reaction. Here you will say CH3Br. I will show here their lecture that is regarding what type of alkane, what type of haloalkanes are to be explained in SN2 reaction. That will be discussed in another class. Okay, thank you. Subscribe my channel, like my lectures, so that I will refresh myself easily, and I just want to refresh myself with the new students. Thanks overall.